Geothermal energy is one of the most efficient ways of generating electricity, due to the fact that it runs all year round and it never stops working because the water that is used drips back into the Earth's core and is reused again when it heats up. The Earth's core never cools, meaning that the water will always reheat, so they don't have to put energy into making sure the water is hot enough to produce steam. There are 3 types of technology that are used when making geothermal energy. These technologies are the binary cycle, flash steam, and dry steam. Dry steam was the first method used when creating geothermal energy. When using the dry steam method, steam travels directly to a turbine, which then makes a generator work, which produces electricity. When energy plants use the flash steam method, they take high pressure hot water from deep inside the earth, which they can convert into steam, which powers the turbines that make energy. The water they use in these power plants goes back into the earth so that they can use it again. The flash steam power plants are the most common type of geothermal energy around the world. The binary cycle is the last method. They use this method by transferring geothermal hot water to another liquid, which then causes the other liquid to produce steam, which drives the turbine to move, causing the generator to produce energy. Geothermal energy is used in over 26 countries around the world, but one country that uses it stands out. Iceland have 6 geothermal power plants in the country. The biggest one they have is the Hellished Geothermal Power Plant. This power plant is ranked 6th biggest geothermal plant in the world. The plant produced geothermal energy by using the flash steam method, which is used by boiling hot water to create steam, making the turbines work to produce energy for the small towns around the plant. The plant's output was 303 megawatts of electricity and 400 megawatts of thermal energy.
Geothermal energy is a renewable source of energy as heat is continuously generated within the Earth's core. This heat is generated from the rapid decay and fission of radioactive materials present deep within the Earth. Geothermal energy has many uses, such as heating, cooking, bathing, and electrical power generating. To produce power from geothermal energy, wells are dug a mile deep into the underground reservoirs to access the steam and hot water there, which can then be used to drive turbines connected to electric generators. Geothermal energy is considered a carbon-free supply of unlimited energy. Geothermal energy only produces 1/6 of the CO2 produced by natural gas, and the overall potential of geothermal energy is estimated to be as low as 35 gigawatts and as high as 2 terawatts. Geothermal energy is considered to be one of the most sustainable energy sources due to its seemingly unlimited supply of heat. Even in geothermal areas dependent on a reservoir of hot water, the volume taken out can be re-injected, allowing it to be heated up and used again, making it a very sustainable source of energy. Geothermal energy has had some social impacts such as land disputes, since the geothermal factories and buildings require large and specific land so that the plants can be used. In some cases, indigenous groups have lost part of their land due to these factories going up, which causes problems between the government and the Aboriginal people of the area. Coal also requires certain land but does not require as much space as a geothermal power plant. Coal is also unsafe to work with, causing an unsafe work environment compared to working with geothermal energy. Geothermal energy has a very positive influence on the environment as it does not affect it as much as fossil fuels do. Geothermal energy does not need to burn fuel to produce electricity, but the plants still do release a tiny amount of carbon dioxide and sulfur dioxide into the atmosphere. Geothermal power plants emit 97% less acid rain causing sulfur compounds and about 99% less carbon dioxide than fossil fuel power plants of similar size. Geothermal energy plants can require a large amount of capital at the beginning due to the fact they need to buy a large piece of land at the right place and the equipment that is needed that can be expensive if you plan on producing a lot of energy within the plant. Coal, on the other hand, is more inexpensive, but it does more damage to the workers and the environment than geothermal energy would. If you look long-term, geothermal energy will be better financially because you are not buying fuel to burn for electricity. You are just using the water that is used before to generate a large amount of energy. Both coal and geothermal energy are very efficient, just coal is not as sustainable long-term compared to the geothermal energy. Geothermal energy currently accounts for 0.4% of net electricity generation in the United States alone. In 2018, the US generated the most geothermal electricity in the world, more than 18,700 gigawatt hours. It's 2 a.m. and I don't want to read this, so here you go.